morning, Manindra. Here today we are going to get into the GATE classes under civil engineering, and we are going to look into environmental engineering. And myself, Karthika, Department of Civil Engineering, SA Engineering College. So, for the GATE civil engineering under the section 5 environmental engineering, the syllabus which includes the water, wastewater quality and treatment, air pollution and municipal solid waste. And today we are going to be looking into the water quality standards and the water treatment process, which is involved the unit process and unit operation. So let us look into the sources of water. We have the raw water that can be obtained from two categories. One is the surface source, under which we can get the source as ponds and lakes, streams and river, storage reservoirs and ocean. But ocean, as it is having a lot of salt content, the newest technologies, even that can be adopted as a surface sources of water. So the next category is the subsurface sources, or it is also called as the underground source of water, below which it contains the springs, infiltration wells and wells. So springs are the naturally available water which is present underground, whereas the infiltration wells and the wells have to be man-made. Infiltration wells has to be constructed near the river where there is abundant quality, good quality of water. There we can build the infiltration wells. From that we can tap the groundwater. And wells also can be an open well that can be constructed where the groundwater level is high. So, in that water quality standards, what are the quality standards we require in our drinking water? So, the water quality standards for the drinking purpose, we need to analyze some physical, chemical and bacteriological characteristics. And now, so the physical characteristics, so as the name indicates, the physical characteristics, by viewing and by seeing we can say whether the water is having the good characteristics or not. So under which some of the physical characteristics like turbidity, color, taste and odor, temperature and specific conductance can be measured, from which we can ascertain as the water is having the required quality or not. So next is the chemical characteristics. So below are some of the chemical characteristics, say pH, acidity, alkalinity, hardness, chlorides, iron solids and nitrates. These are some few chemical characteristics. We need to measure this in our water which we are going to be drinking. That has to be tested, and whether all these characteristics are fall in the standards, that we need to check. And next, the biological characteristics, where there may be presence of aerobic, anaerobic and facultative bacteria. Actually, any sort of microorganism should be absent in our drinking water standards. That also has to be checked in our drinking water. So now we have seen the sources. So the raw water, which will be containing a lot of suspended, colloidal and dissolved impurities. So from the health point of view, we are in the need of treating our waste in our water and then taking to the consumers. So what are the purpose of water treatment? So we need to remove the color, dissolved gases, turbidity, we need to remove the taste and odor, and especially the microorganism, the disease causing microorganism should be absent in our drinking water. And there are hardness will be present in the water, that should be removed. And our intent is that water should be used for the drinking water, domestic purpose, industrial purpose, for everything. It has to meet the required standard, then only it should reach the consumer. So, to treat the raw water, we have certain unit operation and unit process. So, first let us see what is unit operation. The unit operation means we are removing the contaminants from the raw water by using the physical forces like gravity and screening. Unit process is something which we can use a chemical or biological treatment to treat the water. So that is the basic difference between unit operation and unit process. So we are treating the water either by unit operation or by unit process. So we have two types of water, as we have seen in the sources of water. We have a groundwater source and as well as a surface water. But the groundwater and surface water, they have their own characteristics. Say in groundwater we have the constant composition because which is underground. It will not be disturbed by the surface criteria. Whereas in the surface water the composition is varying. In groundwater you have the high mineral content because which is present under the soil. So whatever the soil is having some mineral, that will be absorbed in the water. So automatically this groundwater will be having high mineral content, whereas your surface water will contain only low mineral content. And this having low turbidity in groundwater, high turbidity, because high turbidity in surface water because it is open to atmosphere, and there are activities of the human beings as well as the animals which will be giving turbidity to the water. And it is low colored, and there it is colored, and low or no DO, that is dissolved oxygen. There is dissolved oxygen will be very less because there will not be any space for the oxygen to get into the groundwater. Therefore, low or no dissolved oxygen. Whereas our surface water is open to atmosphere, therefore it will be having the plenty of dissolved oxygen present in it. And hardness is definitely high in the groundwater because of the presence of the carbonates and bicarbonates of calcium and chlorides, sulfates will be present in the water. So therefore the hardness will be higher. And here the surface water is not having the high hardness. And another problem with the groundwater, it will be having the high iron and manganese. And this surface water will be having some sort of taste and odor, and that is the basic difference between the groundwater and surface water. So when we are treating the groundwater, we have to have the different water treatment process. When we are going for a surface water, then the treatment process should be altered. Now let us look into the flow of the surface water treatment. So the raw water, the flow goes like this. We are taking the raw water, we are taking to the screening chamber, and it goes to the coagulation process where we are adding alum. And coagulation is followed by flocculation, and it is followed by sedimentation, and next process is filtration, and then we are disinfecting the water, we are storing the water, treated water, and finally we are distributing. So this is the outline of the surface water treatment process. Here in three processes like screening, sedimentation and filtration, the sludge will be accumulated. So sludge, again it is another process of removing sludge from the water treatment process. So this is another flow chart, whatever is explained previous, just in a diagrammatic way. So surface water we are getting from the surface source, and we are doing the screening operation, and we are adding the coagulants for the rapid mix, and it goes for the flocculation basin and goes for the sedimentation basin where the sludge is formed, and followed by the sedimentation is the filtration. In filtration, most of the water treatment process we use the sand filter, and after which it goes for the disinfection, and we are storing the water, and finally we are distributing to the system. Now the groundwater treatment process, a slight alteration is being done in the groundwater treatment process, where again it is also followed by screening, coagulation, but aeration is involved. Why aeration is involved? Because as we have seen the characteristics of groundwater, it is containing lot of iron and manganese. So iron and manganese, if it is present in excess, it should not be present in the drinking water. So when we do the aeration process, that we supply the abundant amount of oxygen, it removes the iron and oxygen from the water. So we are including the aeration, and it is followed by flocculation, sedimentation, filtration, disinfection or chlorination, and followed by the line dosing. Why we are doing the line dosing? Because this is not there in our surface water treatment process. Line dosing is done because as we have seen, the groundwater will be having hardness. In order to make it soft, to softening we are adding the lime. So that is the brief about the groundwater treatment process. Let us see one by one process of the water treatment process. So first one is the screening, where we are removing the large solid like the objectionable matter like logs, branches, rags, some fishes, that will be removed using a screening operation. So this is comes under the UH operation, where we are not including any chemical or biological process, only the physical means we are putting a screen, and the water which passes through the screen, the floating matter is being stopped there and the water gets into it. And why we are having the screen? Because we need to protect the pumps and pipes in the water treatment process. The consequent process should not be disturbed. So we are including the screening is the first operation. So screening, we need to exclude the large size particles like debris, animals, trees, branches, etc. And the screenings is of two types. One is the coarse grain and the fine grain. So core screen will be having about 2 to 10 centimeters center to center. The rods will be placed. Whereas your fine screen will be having a fine wire mesh of 1 centimeter. So the core screens is removing the floating bodies and the organic solids, where the fine screens removes the fine suspended solids. Sometimes the core screens may be provided with inclination for about 45 to 60 degree. It is meant for easy cleaning. Why we are providing the inclination is because the solids which are getting trapped in the screens has to be removed easily. It has to be raked. For that we are giving an inclination of about 45 to 60 degree. And we need to, in the design process, we need to have that the velocity should not be 0.8, it should be between 0.8 to 1 meter per second. So that has to be maintained in the screening design. So next is the coagulation. Why we are adding the coagulation process in water treatment process? Because there are some colloidal particles or the smaller particles which cannot settle down on its own. So that particles which will be completely of negative charge. So that particles has to be removed because they will be just floating, suspended. They cannot be removed under the sedimentation or screening process. We are adding some coagulants. What are coagulants? They are the positive charge particles. When the negative particles and the positive, they come together, they neutralize and they become like a bigger particles. When the size is increasing, then automatically it settles down. So in order to ease the process, we are adding the coagulation. That is the process called coagulation, and we are adding a coagulant. What coagulant we generally add is the aluminum sulfate, ferrous sulfate, ferric sulfate, ferric chloride and lime. So the most commonly used is the aluminum sulfate, which is widely called as alum. So alum is cheaper, but iron salts, all the ferrous, ferric and ferric chloride, they are more effective for the wider range of pH, because water may having different pH levels. So under different pH, the iron salts works better, but the aluminum salts are widely used because it is very cheaper. So next comes the flocculation. So once we have done the coagulation process, we need to mix the coagulant. So this diagram where the raw water is getting inside the flash mix. Flash mix is where we are adding the coagulant. The coagulant has been thoroughly mixed for a higher RPM, and then it goes to the flocculation tank. We are reducing the speed, high speed to medium speed and low speed. This is because here in the flash mixing, the purpose is to mix the coagulant completely into the water, and in the flocculation our purpose is to get the flocks to be settling down without any turbulence. So we are bringing the low speed, and finally it moves to the next treatment process is the sedimentation chamber. So that is coagulation followed by the flocculation. So this is a setup where which is showing this is the highly turbid water. We are adding the coagulants and the particles are getting like a small flocks, and it is able to settle down, where now we can see the clear water. That is what is going to be happen in our water treatment process when we are doing the flocculation. So plain sedimentation, as the name indicates, the plain sedimentation means we are not adding any coagulants. We are making the water to stand for a while for a detention period of about 2 to 4 hours, where by gravity the particles they settle automatically down, the sludges which are formed down, and the clearer water which is being taken to the next set of operations. So that is about your plain sedimentation. This basin is also called as settling tank, sedimentation tank or clarifier, and the time which is required for the water to be staying in the tank is called as the detention time or the detention period. So what is the objective of sedimentation? Like, we need to make the suspended particles to settle down, which is having the specific gravity of more than 1. So the problem with the settling is the forces which resist the settlement of particle or viscosity, velocity, shape and size of the particles. That matters how the settling is taking place. So that is the purpose of sedimentation, is to remove the suspended impurities. With the help of the plain sedimentation, we can remove the silt, sand, and with the help of sedimentation and the coagulant, we can even remove the fine suspended particles, and some bacteria can also be removed if we are using the coagulation. So plain sedimentation is one which we are not having any coagulants added, whereas in some places we can add the coagulants so that some of the toughest particles which cannot be removed by gravity settling can be removed. So this picture shows a sedimentation tank which is there in a water treatment plant, where the sedimentation tank usually be of a circular basin or a rectangular basin made of it is made up of RCC. Okay, so it is made up of reinforced cement concrete, maybe rectangular or circular in pan. In plain sedimentation under normal condition, we can remove up to 70% of suspended impurities. So the 70% of suspended impurities are removed from the plain sedimentation process. So next operation is the filtration. So whichever particles has been escaped to the sedimentation process or the screening process, then it has to be removed. The next operation is called as the filtration. So it is the important stage in purification. It removes the fine suspended impurities, colloidal impurities that have escaped the sedimentation tanks. In addition to that, not only your suspended and colloidal impurities, also some of the microorganisms are largely removed in the filtration process. So filtration. So the main process is that in the filtration we are using the filter media. In the filter media, the water is meant to pass through. Then filter media arrests the fine suspended particles, colloidal particles, and then it leaves the treated water to the other side. So here filtration also help in removing color, odor, turbidity, and some pathogenic bacteria. So in filtration we are using some of the filter materials. The widely used filter material is the sand. That is being used in all of the water treatment process, because sand is easily available and it is also having the good properties of a filtering mechanism. So when we are going for a sand, what are the characteristics it should possess is that that is the sand which is obtained from the rock like quartzite, and the sand should be free from dirt and other impurities, and it should be of uniform size and should be hard and resistant, and it is passing the acid test. It should not lose 5% of its weight. So we need to check about the effective size, because if the sands are very bigger in particles, then there is no the particles, there will be lot of voids and easily the impurities will also be getting to our water. So we need to check the corrective size and then use for the filtration process. So apart from the sand, we can also use gravel and anthrofilter. So gravel is generally used below the sand, as you know, after the sand we can put some layers as gravel, and its density should be 1600 kg per centimeter cube, and it can be placed as 3 to 4 layers of 15 to 20 centimeter depth, and with 20 to 60 centimeter placed at the bottom. And apart from that, we can also use anthrofilt. So anthrofilt is the another medium. Instead of sand we can use as anthrofilt, but it is made from anthracite. It is like a coal stone. It is not generally adopted in India, but in abroad where the sand is not available, they use the another filter material is called as the anthrofilt. So in filtration there is 4 mechanisms which is taking place. One is the mechanical straining, flocculation, sedimentation, biological metabolism, and electrolytic changes. So when we see there is filtration, we see that is the sand is used as a filter medium, and the impurities are getting deposited on the top, and the clear water is coming out. That is the only criteria we know. But apart from that, there are different processes which is taking place in the filtration. Mechanical straining, after that is flocculation and sedimentation, and biological metabolism and electrolytic changes. So that mechanical straining is that the particles which are of bigger size than the voids will be strained on the topmost layer of the sand, and that is the water which is free from the impurities will be passing on. So that is your mechanical straining. In flocculation, what happens is that in the sand bed there are voids. This voids is acting like a sedimentation tank, and the particles which are depositing is forms as that coagulant mass is forming, and that mass is attracting the impurities, so that again it is adding more filtration mechanism to the filtration process. So that is about flocculation and sedimentation. And in biological metabolism, what happens is that there will be a lot of microorganisms present on the topmost layer of the sand bed. So this microorganism, they feed on the organic matter present in the water, and they release the harmless compounds films that is being formed on the topmost layer of the filter bed. So that we generally called as the dirty skin. So this layer further helps in absorbing and straining out of the impurities. So electrolytic changes. So apart from that three mechanism, we have another mechanism is that we have the electrolytic changes. That is theory of ionization. Because we have that that impurities, that is the impurities as well as the filter media, they carry the opposite charges, positive and negative charges. When they come contact to each other, they neutralize, and due to the neutralization the water gets purifier, and this mechanism also helps in the treating the water. So in filter we have the three types of filter: slow sand filter, rapid sand filter and pressure filters. So slow sand and rapid sand filter are classified based on the rate of filtration. So rapid sand filters are having the filtration rate of about 3000 to 6000 liters per meter square per hour. Whereas pressure filter is the closed one, where we are applying pressure and the filtration process is taking place. And the last process is the disinfection. So in the disinfection we add some chloride, that is chlorine, to remove the or to kill the microorganism from the water. So this is about the brief or outline about the water treatment process which is taking place in a water treatment plant. Thank you.